in one place.
It's going right now! Which is funny because I have to turn this on first. So, a story about pyramid schemes. Okay, so gases, we're going to the notes really quickly. And hopefully
Can you just stand in one place and talk? Does that make more sense?
If we get done,
Because see, now I'm going to be paying attention to this and not what he's saying, so I'm not going to learn anything.
Hey, are you
Sorry.
filming?
Yeah.
Oh. Let's cut this out. Can you see anything out?
No.
It's broken.
Making
Shit, if you hit
Should
the
have filmed
lights.
later. Yikes. Can you say train wreck?
Train wreck.
Well, you can.
It's up.
Okay. Gases. We'll spend the day talking about sort of these topics tomorrow too. Thursday and Friday we have sort of bigger plans. What are they?
Watch tournament.
Yeah, so we got to make sure they get some worksheets in there somehow, right? Anyway, let's go for play Thursday, yes, or Friday?
Go for play Friday.
11:05 during this hour. What? The game will finish during this hour. Okay, gases have unique properties. I kind of got into this during the demos. The distance between the particles is much greater than a solid or liquid, so they're very compressible. Actually, a gas is mostly empty space, and those distances are very great.
I thought you said you wanted it on you when you're
No,
talking.
this part one is this thing, and then people write that, and then you come back to me because I'm gonna say something really witty,
Okay.
or at least interesting, or at least something, probably not either of the words. So, gas is very compressible. You saw that for the demo with the crush can. Crush can because you're taking a lot of space the gases take up and greatly reducing it. They're considered fluids because they flow around one another. The molecules have enough space to move past one another. So the term fluid is any substance that can flow, which is sort of a terrible definition. But
It's pretty
any
bad.
liquid or gas is going to be considered a fluid. And they can flow because they're far apart from one another. That's very important. And so when we're like walking around in the atmosphere, we're actually walking through the sea of gas, and it's considered a fluid. Or you think if you end up taking chemistry or some sort of engineering class in college, you might take a class called fluid dynamics, which is like learning all about how stuff moves through water and in the air and through the atmosphere. If you think of those car commercials where they always they spray that jet of smoke over the car. Yes, you've seen those? Yeah, that's kind of like fluid dynamics because that's mimicking how a car travels through, the atmosphere when you're on the highway or on your road or whatever. Okay, so gases have really low densities compared to liquids and solids, and most of the volume of any gas is the empty space that it occupies. You know those, my daughter's got a double ear infection right now, which is awesome. And if you ever they give you the medicine for kids, like given a little syringe, like a little plastic syringe, not like one with a needle on it, because you don't jam a needle in her mouth, but like a little plastic one. Familiar with these? Mm-hmm. They exist. If you put your hand over that, I didn't bring one today, but and you put some liquid in it, let's say water, you can't really move the plunger that much, okay? But if you fill it with gas, and then put your hand on, you can actually move the plunger quite a bit because the gas is very compressible, whereas liquids and solids are not as compressible. And that's to do with the distance between the molecules. If there's a lot of space between the molecules,
Don't
that means
worry,
you can
I got
compress
that.
them. If there's not a lot of space, if a solid or a liquid, you can't compress them that much. That's what you said. So you'll find out tomorrow that pressure and volume are inversely related. As you increase the pressure, you move the gas particles closer, and then you'll decrease the volume. Now gases, since they're so compressible, there's so much space between them, you could take all the gas in this room and compress it down into a workable size, like let's say one of those air tanks that you use to go scuba diving. Okay, that holds a ton of gas, but it's all compressed in there. And then when you open the valve, obviously the gas comes out because there's more pressure in there. But the point of the matter is that you can take a lot of gas and put it into a very small place and still retain all the properties of that gas, as long as the container is strong enough to hold it. And then if this room were empty, let's say, and you had one of those containers in it, like let's say there's no gas in here, there's a vacuum in here. If you open the container up, then the gas molecules will move from high pressure to low pressure, and so they'll fill the room. So you can and a gas is unique in that it fills the whatever space it's in. The only thing that won't change about it is the number of particles. Like if there's 2 moles of gas in this container, and you open it up in here, it flows out into here. There's still 2 moles of gas, but now it's got a huge volume because it's spread out so far in the room. What does this say? Yeah, I just said that. Well timed. It's like I taught this first and third hour.
Yeah.
We got a lanyard. St. Thomas lanyard. Choose to say you want to
Yeah, really.
What?
Lazy shit.
What?
Dang it.
Did you say the S word on the video?
I think he just did.
We're gonna play it back.
Okay.
Not right now.
They did
I
pick
got
up.
Well, they don't know who you are, I guess. I haven't said your name or anything. Anyway, so gas and exert pressure. You don't feel the pressure of a gas because you've been kind of living with it your whole life. But the trillions of the gas molecules are constantly bumping into things and bumping into your skin and stuff, and they all have mass. And so when they bump into you and they have mass, they transfer some energy to you, they transfer some force to you, and that we collectively call air pressure. And pressure, the scientific definition, is the amount of force per unit area of surface. The amount of pressure increases as the surface decreases, and so that's why if you step on a nail or like a thumbtack, let's say a nail, that would hurt your foot pretty bad. But you can actually, like, you've seen people lay on beds of nails because then you spread out the surface over a larger area, and that's easy, that's less effect on your body. In the United States, do you know how we measure pressure? What?
PSI.
PSI, very good. And so when that little orange weathercaster on Care 11, sort of like a Oompa Loompa, Sven Sunderland or whatever. Is that the channel you watch? It's orange. I've seen the one around Lake Erie. It's very orange. Anyway, they use a barometer. It's very tan. It's sort of fakeish.
Yeah.
Anyway,
It's kinda
they use a barometer to measure the pressure in the atmosphere because that varies a little bit with weather systems and stuff. A barometer is, if you've been in Miss Dunn-Silson's class, she has one here. It's sort of a J like this. It's a giant tube. It used to be filled with mercury, but it can be filled with anything. But typically it's mercury. But mercury is sort of like not safe. And it's open at both ends. And when the air pressure increases, that pushes down this way. And so the gap or the mercury, so the liquid, goes up this way. Yes. See the relationship there? And then when they say, they'll report this on the weather. Do you know how they report it? When they say the barometer is what? Can they report it? Do you watch that?
Who watches the weather? I don't know.
Like, they usually in America they measure it in inches, but it's you'll find out it's millimeters in this class. But so they measure this distance, this distance from the bottom to wherever the top of the line is, and they report that in inches. And so for high pressure systems like weather systems, there's more pressure out here, so the barometer goes up. In this part of the country, it's usually around 28 or 29 inches. This distance is. And then if it's a low pressure system like rain or something like that, then there's less pressure here, and so this one goes down. And that's how they measure the barometer. And it's pressure is kind of important for weather. So. In this class, there's 3 ways to measure it. So you're going to kind of convert between 3 different units. It's sort of like saying inches and feet and centimeters. And they're all they're measuring the same thing, but they're all reported in different ways. The SI unit of pressure is called the Pascal. It's called the Pascal. Do you already have that?
Yeah.
Sorry. My voice keeps cracking. I think my voice keeps cracking because I was up so late last night. Shut it down. So there's the Pascal, there's also the the mercury is measured in millimeters in this class, which we'll get to in a second. And so instead of having all these different units, you can have millimeters of mercury, you can have inches of mercury, you can have the Pascal, the kilopascal. Someone just came along and said, hey, why don't we let the pressure at sea level be 1, and then go from there. And so that's 1 atmosphere, that term's atmosphere. So all 3 of those numbers measure pressure. I'll write them on the board in a second for you. And you'll use all of them, and you're expected to be able to convert between all of them, so keep that in mind. You already saw that as we change temperature and pressure, things happen. Volumes change, the amount of stuff can be different. And so scientists thought it might be useful to have a standard set of conditions. And then they really thought outside the box, and they call it standard temperature and pressure, STP. And that's 0 degrees Celsius or 1 atmosphere of pressure. So essentially 0 degrees Celsius, the freezing point of water, 1 atmosphere would be obviously the pressure at sea level. And that's kind of what a standard temperature and pressure is. Just so that if you're doing an experiment here, or if you're doing one in Czechoslovakia, you do it at a certain set of conditions so that the results are repeatable. Because if you did something here and then did something in Czechoslovakia, and had to do with gases, it would not be the same. You notice pressure changes all the time. If you ever go to the north, to Minneapolis, to my house, when you cross the river, you can feel your ears pop sometimes because you're decreasing your altitude, and so there's more gas sitting on top of you that increases the pressure. Or if you're in a plane that's not, the cabin's not pressurized correctly, you can feel your ears pop when you go up in the air, obviously, because as you go up over all this air, there's less pressure, there's less air sitting on top of you. Or even if you travel a little bit, just like going up and down on the mountain or rocky incline. So there's lots of pressure changes. Let me draw the 3 on the board for you, because I'm not going to get to the next part. Tell us a story about first half. All 3 things are related. They are, this is all the pressure at sea level, so that's 1 atmosphere. These numbers you should memorize, which is equal to 760 millimeters of mercury, which is also sometimes called a torr. They mean the same thing though, just in case, just throw in there to confuse you. And then that's also equal to 101.3 kilopascals, kPas, just by coincidence. I know of those numbers, the one that you'll remember. It's the one that plays Louise or whatever. Whatever your kids listen to. Louise or Lady Gaga
All the time.
or
Again,
Britney Spears or whatever. Anyway, so these 2 numbers are related. They're all the same. You can use them to convert. Much like you would say 12 inches is 1 foot, and you could say how many inches are in 2 feet. If I told you that I want to know how many kilopascals were in 15 atmospheres, you just take 15 atmospheres. And if we're doing the official conversion, you'd say that in 1 atmosphere, like this, because you want them to cancel, how many kilopascals are in 1 atmosphere?
101.
Very good, 101.3 kilopascals. And then you just take 15 times 101.3, and that would allow you to convert between kilopascals and atmospheres. There'll be a fair amount of this in the homework, I believe, so keep that in mind. Do you have any feelings about that? I'm going to stop there. We're done. You hit the stop button.